Instead of hoping for a fountain of youth, what if when it comes to aging, we knew how to age well rather than just trying to stay young forever?
Research into that very idea is happening right here in San Antonio at Texas Biomedical Research Institute. And this goes well beyond the gray hair and the wrinkles. There, scientists are looking at the lungs and the gut for clues on how and why our bodies change as we get older. Here's KSAT Explains. No matter who you are or where you're from, we all do it. We age. But how we do that can be drastically different.
Even though we're 99% identical in our DNA, the building blocks of life in our bodies, we're completely different in the way we respond to this time clock over our lifetime.
Researchers at Texas Biomed want to know why, and they're looking at those building blocks of our bodies, the things we all have, to find the answers. One of those foundational biological components? Our cells.
The longest thinking in the area of aging is that things just stop working. It's called senescence.
But researchers here are discovering there's more to it than that. And the aging process starts even sooner than you might expect.
That clock actually, sorry to say, starts relatively early in life. A lot of the science is really centered around that third and fourth decade, where this clock starts ticking towards.
So what does all that have to do with these guys?
Marmosets are a unique non-human primate because they're small, and so they reproduce quickly and they have a shorter lifespan.
Marmosets have systems similar to those in humans. In their roughly 8-year lifespan, scientists can learn a lot about how these animals age, and therefore how humans age as well. In the marmoset, scientists here are looking at the gut and what's called the microbiome, the naturally occurring bacteria and viruses that live in your gut.
And so for the marmosets, we've found that their microbiome changes the same as humans change as we age. We lose that diversity. We lose the access to nutrients from the microbiome. So our questions revolve around what happens if we transfer in a younger microbiome. We're looking to see if that transfer of young will restore gut health, reduce inflammation, restore cognitive health.
All things that deteriorate with age. New research has already shown that improving gut health could delay or even prevent dementia. It's an area of study called the gut-brain axis.
Fecal microbiome transplants are becoming a common clinical treatment.
Yeah, that one needs a little more explanation. What is a fecal microbiome transplant?
Well, it's kind of gross, but basically they've taken fecal material from healthy individuals. They're called super donors. They have very healthy microbiome. They pellet that into pills and they transplant it, or they do a surgical transplant for individuals that are very ill.
There have been studies that show transplanting a fecal microbiome from a lean mouse to an obese mouse helps the heavier mouse lose weight, and transplanting a microbiome from an obese mouse to a lean one helps the lighter mouse gain weight. But this isn't just about what one mouse or one human versus another chooses to eat.
Some of it's diet. It's how the microbes are responding to diet, but a lot of it's our own DNA. It's what we were seeded with when we were born. That community took root in our gut.
It's also what we're exposed to. Antibiotics affect gut bacteria, even stress. Texas Biomed scientists are also looking at the lungs for clues about aging. And the pink stuff in this cup is a groundbreaking way to do it.
We called it as a magic cocktail.
This cocktail, invented here at Texas Biomed, mimics the environment inside human lungs. Getting a sample of an actual human lung isn't easy, and it got even harder during the pandemic.
The scope goes down and we can wash a segment of the lung and get cells from there. It's expensive. It results in a small number of cells, and we can only do certain studies for that environment.
But with this mixture, these researchers can isolate cells pulled from a blood sample, add them to this solution, and a few days later, they have cells that function like those in a human lung.
Necessity is the mother of invention.
And so the excitement of understanding the cellular basis of aging is that maybe that's a way to slow the aging process down.
An entire industry is built around aging. Products, supplements, everyone looking for that magic something.
You see probiotics on the shelf, eat this yogurt, eat this thing because it'll make you healthier. We're just starting to study what those effects are.
The research here isn't about that, nor is it an effort to keep us all young.
This is about functionality and maintaining that functionality as long as possible.
I don't have any interest in increasing longevity. Humans live long enough for the world and resources that we have.
I don't think this is about cure or having us live forever. It's simply about trying to reduce the chances of frailty coming into our lives earlier.
If we can prevent that and push that off, and not every 80-year-old will run marathons, but it would be great if they were healthy enough to have that option.
So this isn't about stopping aging, but more learning how we can age well.
Right, we want to age well.
You can watch this and all of our KSAT Explains coverage on a wide range of topics by scanning this QR code. Look for our stories on the KSAT Plus app as well as the KSAT YouTube page.